Building automation pipelines, especially those interacting with external APIs, quickly teaches you one thing: stuff breaks. Not sometimes, but often. APIs rate limit, network connections drop, an unexpected null value crashes a function, or the entire script just gets unexpectedly terminated. For a long time, my solution was to just restart the script from the beginning, maybe add some basic try-except blocks. But that's inefficient, costly, and completely impractical when you're processing hundreds or thousands of items. If my video generation pipeline failed on item 47 of 100, restarting meant regenerating 46 videos again, re-hitting APIs, and spending more money than necessary. I needed a way for a script to not just handle an error gracefully, but to remember where it left off and pick back up. That's where the concept of a job queue came in. But I wanted something dead simple, zero external dependencies beyond Python itself, and virtually free to run. So I built one with SQLite. My core problem was state management. A simple Python script executing tasks sequentially has no inherent memory beyond its current run. Once it crashes, that memory is gone. The solution, I realized, was to externalize that state. Rather than keeping track of current item index in a variable, I needed to store the status of each item in a persistent database. SQLite was the obvious choice for a single server, low-cost setup. It's file-based, meaning no server to manage, no network latency, just a simple .db file living right alongside my Python script. The first step was defining a schema that could track the lifecycle of a task. I settled on a straightforward table called jobs. The jobs table, at its simplest, contains an ID for primary key, a status field, a payload field to store the actual data needed for the job, created at and update at timestamps, and a retries count. The status is the critical piece here. I typically use pending, processing, completed, and failed. When a new item needs to be processed, I insert it into the jobs table with the pending status. My Python worker script then queries for pending jobs, picks one, updates its status to processing, performs the work, and then updates the status again to either completed or failed. This simple transition model is what makes the pipeline resumable. Let's look at the core worker logic. My process job function is where the actual work happens. Before starting any heavy lifting, the worker first fetches a pending job. A key aspect here is marking the job as processing before attempting the actual work. This prevents multiple workers from picking up the same job in a concurrent scenario, though for most of my solo automation scripts, I only run one worker. More importantly, if the script crashes after marking it processing, but before marking it completed or failed, the job remains processing. On the next run, I can configure the script to either reprocess processing jobs, or, more safely, mark any stale processing jobs back to pending if they haven't been updated for a certain time, allowing them to be retried. Error handling within the process job function is straightforward. Any exception caught during the actual task execution leads to marking the job as failed and incrementing the retries count. I usually implement a simple exponential backoff or a maximum retry limit. For instance, if a job fails 3 times, I might move it to a dead letter status or log it for manual inspection. This prevents an unfixable job from perpetually blocking the queue. This pattern significantly reduces mental overhead. I don't need to manually track which video script failed or which API call broke. The database holds that state, ready for the next iteration. One critical detail for robustness is using transactions. When you fetch a job and then update its status to processing, you want both operations to succeed or fail together. If the script crashes between the select and update statements, you could theoretically have race conditions or an item that's picked but never marked processing. By wrapping these operations in a SQLite transaction, con.begin and con.commit, you ensure atomicity. If anything goes wrong, con.rollback ensures the database state remains consistent. For my simple jobs table, this means that selecting a job, marking it processing, and committing that change happens as a single, indivisible unit of work. The cost of this system is essentially zero. SQLite runs locally, on disk. The processing time for database operations is negligible compared to any external API calls or heavy computation I'm doing. The only cost is the disk space for the .db file, which for hundreds of thousands of jobs is still measured in megabytes, maybe a few gigabytes at most. Even running on a tiny VPS, this pattern adds literally pennies to the monthly bill. It's a classic example of using the right tool for the job. You don't need Kafka or RabbitMQ for single-server, fault-tolerant Python automation. Sometimes, the simplest solution is the most effective and the cheapest. This SQLite job queue has become a foundational pattern in almost all my automation projects, especially for the faceless YouTube channels I build. It handles the video script generation, the voiceover synthesis, the video editing commands, and the final upload tasks. Each stage is a job, queued and processed resiliently. If Claude API goes down for an hour or 11 labs rate limits me, my pipeline doesn't break. It just pauses and resumes from the exact point of failure. It's transformed brittle scripts into robust, set and forget systems. If you've been battling with fragile automation, I encourage you to try the simple SQLite pattern. It might just save you a lot of headache and a good bit of money. If you'd like to see a deeper dive into the full video generation pipeline where this is used, let me know in the comments, and don't forget to subscribe for more real-world developer stories.